Alright, today we're going to go through our Unit 5 review on chapters 13 and 14. To begin, number 1, the answer to a multiplication problem is called a product. Alright, number 2, list the 5 multiples of 6. So first we're going to start with 6, and then we're going to add 6 to every next one. So the next one would be 12, 18, 24, 30, and ending with 36 gives us an extra one, but you only had to go to 30. Next, we're going to find the prime factors of 30. So to find the prime factors of 30, you always want to make a factor tree. Putting 30 at the top, break that down. You could do a few different ways. You could either do 5 and 6, or you could do 3 and 10. I'm going to choose 3 and 10. So then we found that 3 is a prime, but we still need to break down our 10 to 5 and 2. We find that 5 is a prime and 2 is a prime. So we can end there, and just to list out our primes just so it looks a little neater, we always want to do it from least to greatest. So we have 2 times 3 times 5, and those are our primes of 30. Going to the next page. Number 4, what is the rule of divisibility for 5s? A rule for divisibility for 5 is anything ending in a 5 or a 0. And you can put that in any way that you wish, any kind of student language that you can write, but I would write anything ending in a 5 or a 0. The next problem we're going to do is number 5. We're looking to see, is 128 divisible by 4? Our divisibility rule for 4 is to see if the last two numbers is divisible by 4. Our last two numbers in 120 is 20. 20 is divisible by 4, so I would say yes. Our next one we're going to do is number 6. Find the GCF, or the greatest common factor, of 9 and 15. So for me, I think today you can do a few different ways. You can list the factors out, you could use a Venn diagram, or you could use factor trees to find this. For this one, I'm going to do just do the listing of the factors. So there's my 9. So I'm going to see if one pair I have is a 1 and a 9. I'm going to put that there. And I think the other factor is going to be 3 times 3, but I only have to write it once. So I'm just going to put that 1, 3 there. Now let's move to our factors of 15. I know 1 and 15, that's our easy one. We know every number has a factor of 1 in itself. The other factors of 15 would be 3 and 5. Now if we look at our two lists, we want to see what we have in common. What we have in common in these two lists are our 3s and our 1s. Every number is going to have 1 in common, but we want to find the greatest common factor. So we are going to choose our 3. So our GCF equals 3. Alright. Next one, number 7. Number 7, find the LCM of 5 and 15. So when we're finding the least common multiple, we think of least as list. So we're going to list out our multiples of 5 and 15. So I'm going to write 5 and 15, and I'm going to make a list. Start with 5, 10, 15, 20, 25, 30, 35, and I think I'm going to stop there, just because I feel like I wrote quite a few. Next one, we're going to do 15, so we're going to start with 15. Add 15 more, we get 30. Add 15 more, we get 45. But as I look at my list, I can see that I can stop there because I already made a pair. Each one has a 30, and that's the, but hey, that is something they share in common, but there's one more number that they have in common that's smaller. We're looking for the least common multiple, so our answer would be 15. So our least common multiple equals 15. You can find more multiples like 30, but that's not our least one, so we want to make sure that we use our least common multiple. Number 8 is going to be looking at divisibility rules. We need to see if 1,526 is divisible by 2, 3, and 6. So first, let's check our rule for 2. Our rule for 2 is that any number ending in an even number is going to be divisible by 2. So we see that it ends in a 6, that's even, so I'm going to say yes. Our rule for 3 is that if we add all the digits together, and and then divide by 3, see if it's divisible. Let's add them up first. So I have 1 plus 5 is 6, plus 2 more is 8, plus 6 equals 14. And I can see if I do 3 divided by 14, I can tell right there that that is not divisible. I know my multiples of 3, and it skips over 14, so that is a no. So I'm going to write no. It's not divisible by 3. Our rule for 6 is if it is divisible by 2 and 3, we can see that we have a check. Yes, it's divisible by 2, but we have an X for 3. No, it's not divisible by 3, so that is a no for 6. Moving on to the next one. Next problem is number 9. List if 308 is divisible by 2, 3, 4, 5, 6, 9, and 10. So now we have to check all of these. So first, I'm going to check 2. 2, again, our rule, if it's even, I look at our number. Yes, it's even, so I'm going to list down 2. Let's look at 3. 3, the rule is if you add all the digits together, 3 plus 0 plus 8 equals 11. 11 is not divisible by 3, so that is a no. So I'll put an X in that one. 4, our rule is if the last 2 digits is divisible by 4. We see that our last 2 is 0 and 8, which is really just 8. And yes, 8 is divisible by 4, so I'm going to add 4 to our list. It is divisible by 4. Our next one is 5. Our rule for 5 is any number ending in 0 or 5. We can see that ends in an 8, so that doesn't work. Put a new line through that one. That doesn't work. 6, our rule is if it's divisible by 2 and 3. We said it is divisible by 2, but it's not divisible by 3, so 6 doesn't work. Now for 9, our rule is pretty close to the same as 3. We add up our digits like we did just here. We have a total of 11, but this time we need to see if it's divisible by 9. 11 is not divisible by 9, so I can cross that out. Our last one is 10 that we need to check. 10, the rule is if any number ends in 0, then it will be divisible by 10. We see it does not end in a 0. It ends in an 8, so 10 doesn't work either. So our only 2 numbers that work for this one are 2 and 4. Alright, so our next one, list the first 6 multiples of 3. So the first 6, that's all we need to do. So first I'm going to start with 3, 6, 9, 12, 15. I think I have 1, 2, 3, 4, 5. I need one more. And 18. Alright, number 11. Find the least common multiples of 3, 6, and 15. So now I have 3 numbers that I need to list all of the multiples. Just like when we talk about least, we're thinking list. So I need to list the multiples of 3. Let's do that one first. 3, 6, 9, 12, 15, 18, 21, 24. I'm going to stop there because that's a pretty long one. We might have to add to it later, but we'll find out. Next number I'm going to list the multiples is 6. I'm going to go 6, 12, 18, 24, 30, 36. I'm going to stop there just to see. We might have to add more. We'll have to find out. Next number we have is 15. 15, add 15 more, I get 30. Add 15 more, I get 45. Ooh, I see a common pair between 6 and 15. I have a 30 and a 30, but I haven't got there yet on my 3, so let's keep on adding some 3s. I think my next one would be, let's see, I have here 27, and 3 more would be 30. There's our last 30. So our least common multiple of 3, 6, and 15, the lowest one that they all have in common, are our 30s. So I write LCM equals 30. Next problem. Number 12, find the LCM, then the GCF for the numbers 15 and 45. So there's 2 parts to this problem. First, we need to find the LCM of 15 and 45. So I'm going to make a list because I'm finding the least common multiple of 15 and 45. So first, I'm going to list the multiples of 15, 15, 30, 45. And I'm going to stop there because I noticed something, is that 45 matches this number. So that is going to be the first multiple of this one. So I think I found my match already. So So our least common multiple equals 45. Now we also need to find our greatest common factor for those two numbers as well. For this one, I think I'm going to make a Venn diagram just because I think it might be a little easier for me to see. So I'm going to draw my two circles. And I'm going to make the factors. So first, I'm going to find the factors of 15. Put that little number in the corner so I see what I'm doing. 1 is always going to be in there, and 15. Another pair would be 3 and 5. Let's move to 45. First one I'm going to write is 1 and 45. That's a pair. Our next one I would do would be 3 and 15. And I believe our last pair is going to be 5 and 9. Now we need to look to see what they have in common between the two. We always will have a 1 in common. The other numbers we have in here I see are a 3 and a 5. I believe that's, oh, I see one more. 15 also. We're looking for our greatest common factor, so I'm going to see that 15 is our greatest one. Our GCF of 15 and 45 is 15. For our number 13, it's exactly the same process that we did on number 12, so I'm going to skip through that one. You would be finding the LCM and the GCF of 6 and 10. We're going to move on to number 14. Give two examples of prime numbers. A prime number is any number that's only divisible by 1 in itself. I would give an example of 3 and 11. Those are my two examples. Now we're going to look at number 15. Number 15 is 4 to the third power. So in this, that actually means 4 times 4 times 4. To find the answer of that, I would multiply those together, and I would end up getting 64. Alright, the next one, number 16, simplify 4 times 4 times 4 times 4. To simplify would mean to make that into a power. Since I have 4 4s, it'd be 4 to the power of 4. To find that answer, I would multiply 4 times 4 times 4 times 4, just like how it was written out up top. Multiply that together, and you should end up getting 256. Moving on to number 17. What is 1 to the 56th power? We haven't talked about this yet, but if you know anything about multiplying ones, 1 times 1 times 1, how many times you do it, it does not matter. Anytime, it'll always equal 1. So I could even have 1 to the 250th power, and that'll always equal 1. So our answer is 1. Alright, number 18. What are the prime factors of 110? I'm going to use a factor tree. We need to use factor trees to find the prime factors. I'm going to choose, you could do a few different numbers, but I'm going to choose 11 and 10. Multiply those together, you should get 110. This is a prime factor right here, so I don't need to do anything with that, but I do need to split that 10 to 5 and 2. I end up getting 5 and 2 as prime numbers, so if I list it from least to greatest, I will have 2 times 5 times 11. I don't have to simplify because there are no duplicate numbers, so I leave it as that. Now, number 19, we're going to move on to a little review, adding using decimals. When we're adding, we want to make sure you line up the decimals. So I would have it like this, and I think I'm going to put that 114 above, just so I have the bigger number out on top. And then I would add those numbers together, so make sure you are lining up your decimals when you're adding. We're going to move to number 20. Number 20, you need to make sure, you don't need to line up your decimals, but you need to keep track of those decimals, the places behind it. Bigger number on top always, and 45. Just so happens that the decimals do line up in this case. They won't always, that's okay. Then make sure when you're multiplying at the end, you're going to count over 4. And put your decimal. Thank you.